Hello everyone, my today's presentation topic is MMIC Technology Chapter 2. Before going into details of my presentation, I would like to give you a short introduction about me. This is Mehedi-Joni. Currently I am studying 4th semester in the Department of Electronic Engineering at Kwangwoon University as a master's leading PhD student. Along with that, I am working as a research assistant in Advanced Quantum Nanomaterial and Optoelectronics Laboratory. My academic supervisor is Professor Jeon Lee, and my ongoing research project is transitional metal-based electrocatalyst fabrication with material characterization for cost-effective green hydrogen energy production. This is the outline of my presentation. Indium gallium phosphate gallium arsenide HBT foundry. First of all, we will talk about the background concept. After that, we will focus on indium gallium phosphate foundry. Furthermore, indium gallium phosphate gallium arsenide HBT process, and we will see the active and passive devices following this. And finally, the layout design rule will be explained in this presentation. In this introduction part, we will discuss some background concept of this indium gallium phosphate and gallium arsenide HBT foundry. The success of the mobile communication is fundamentally underpinned by the advantage in semiconductor manufacturing technology. These have delivered key high-performance components in large volume with high yield, and finally resulting in low unit costs. Currently, the RF circuit designer has greater choice in technology than ever before with the availability bipolar and field effect device process. In this presentation, the basic process sequencing used to fabricate BGT integrated circuits is reviewed. Additionally, it is important to know how to use the foundry company. For this foundry service, a block diagram is the foundry service is shown in the figure number 1. Throughout this curriculum, the overall MMIC technology and layouts and fabrication process are shown. This slide will explain the purpose and practical each step and details. In the foundry service processes, customer use the multi-project offered application, which describe the sharing of the offer and is explained further in chip. Before fabrication, the company requests NDA. It means a non-disclosure agreement submission. Signing the agreement means the customer can never abuse its contents. And the RSR, it means a regular shuttle run, is then verified. After being informed that due to the date the offered design kit is received by the company, here we will use the design kit from the K company, and following the payment of the mask manufacturing cost, the circuit design are submitted. Passing through the DRC, it means a design rule check. Following that, the mask is fabricated. Throughout the PCM, process controlling monitoring, both the customer and company know if the process goes wrong. In addition to the foundry services, the customer service follows the parameters HP8510C, power measurement, it means Maury tuner, and IMD measurement, noise measurement and ATN noise, hot and cold measurements, dynamic loads line measurements, laser trimming, reliability testing, etc. In the foundry services, indium gallium phosphate and gallium arsenide HBT process is included in this part. The HBT process can be separated into two parts for explanation. One part is considered with the transistor aspect, another part is include the rest of the MMIC and its backside. On the top of the basic offer, the 6-inch indium gallium phosphate HBT process progress are shown in the figure number 1. This section makes the chip fabrication process easy to understand for the customer. A chip process considers not only the one surface but also the front and back sides. The front side is fabricated first, then the back side is treated. Figures are given to illustrate each part in following the explanation. In the figure number 2, we can see the configuration of the 6-inch HBT frontside flowchart, and the figure number 3, we can see 6-inch HBT backside flowchart and its configuration. Furthermore, types of process and their merits. Here there are 3 types. One type is HP, another one HL, another one HS. HP means high power process, HL means high linearity process, and HS means high speed process. There are some practical application and some characteristics for each type of process. In this section, for the active device, we will focus on indium gallium phosphide or gallium arsenide HBT devices. The high linearity, in shortly HL, process active device is so named because of the intrinsic device linearity of the indium gallium phosphate HBT, which is the result of uniform current gain characteristics. In turn, the gain characteristics are a function of collector current and the independent collector capacitance and the high early voltage. The thermal conductivity of gallium arsenide is lower than the silicon. Therefore, when the MMIC is designed using a indium gallium phosphide gallium arsenide HBT, the self-heating effect must be considered. A micrograph of indium gallium phosphide gallium arsenide HBT is presented in the figure number 1. Furthermore, the HBT EPI structure is given in the figure number 2. In the figure number 3, the indium gallium phosphide ledge is shown. The purpose of the indium gallium phosphide ledge is to prevent surface recombination currents. In this section, an abstraction of the parameters of WBBIC model is presented. Here, parastatic and intrinsic DC and AC parameters are required to achieve a perfect model. To exact the optimal parameter at DC measurement is carried out by using DC source monitor, for example HP4142B. Additionally, an AC measurement is performed using a vector network analyzer, and then modeling software is used, including the integrated circuit characterization and analysis program and advanced design system package. The modeling device reported in this work is based on the 6-inch indium gallium phosphide and or gallium arsenide HBT device technology, which utilizes one emitter's fingers with a width of 10 micrometer and the emitter length of 20 micrometer. Furthermore, the modeling measurements set up at Kwangwoon University is shown in figure 1, and the table number 1 is show HBT device parameters. The HBT device characteristics are presented in the table number 2. In this slide, we will focus on modeling. In terms of modeling, I have included here BBIC model and extraction of parasitic elements. For the BBIC model, it was developed an industry standard replacement for the SPICE model. The basic equivalent circuit of the BBIC model is presented in the figure number 1. Unlike the conventional SGP model, which has 3 terminals, the BBIC is a 4-terminal model, comprised of a base, a emitter, a collector, and a substrate. On the other hand, extraction of the parasitic elements. I have included here first of all parasitic capacitance. To characterize the AC behavior of microwave transistor, usually a set of 2 ports, S parameters is measured by using a secular network analyzer. When performing high frequency measured on offer, a correction procedure must be followed. The HBT model small signal equivalent circuit is shown in figure number 2. After that, parasitic inductions. The parasitic inductions are extracted by the short patterns, which is shown in figure number 2. And number 3, overlap capacitance. The base collector overlap capacitance CBCO is explained in this part. The capacitive coupling due to geometric overlapping between the base and collector in the HBT can give us right charge feed through. And the figure number 3 is, and figure number 4 is the fitting of the sum CBC plus CBBCO function for the junction capacitance. In this slide, we will talk about the modeling, another modeling part that is called extraction of intrinsic elements. So, first of all, we need to focus on the resistance part. The eccentric S parameter is converted and opted in the above de-embedding method. Next, whole extraction of the parameters are carried out using the intrinsic S parameters. The base collector junction capacitance and the base emitter junction capacitance are increased by applying zero voltage into the both and collector and emitter by simultaneously applying high current into the base. Therefore, the resistors are extracted from the following equations. The resistance below is determined from the average resistance in flat frequency region. Consequently, the value of RE, RB and RC are 1.43 ohm, 1.17 ohm and 1.41 ohm respectively. The figure number 2 is showing the extracted RE, RB and RC. After that, thermal resistance. The self-heating property of the bipolar transistor is important for a variety of circuits using gallium arsenide as the substrate material because of its comparatively low thermal conductivity. The figure number 2 is showing current versus voltage characteristics curve of the calculation method for thermal resistance. And figure number 3 is showing the extracted RTH versus BCE. It means the thermal resistance is defined as the rise of junction temperature above the temperature of any reference point, and it is measured at 25, 50, 75 and 100 degrees Celsius as seen in the figure number 3. The extracted thermal resistance below is 88 degrees Celsius. In this slide, we have included the passive devices that is called transmissional line, and the microstrip is a flat strip of a conductive material separated from a single ground plane by a dielectric material substrate. For example, we can say the gallium arsenide. In the figure number 1, the physical parameters of line metal are shown, and additionally the physical parameters of substrates are given in the table number 1. So, for the parameter, we can see here the silicon nitride dielectric constant, gallium arsenide dielectric constant, silicon nitride dielectric loss, gallium arsenide dielectric loss, and gold plate ABM thickness, silicon nitride deposition thickness, gold plate IM and IMS thickness, gallium arsenide substrate thickness. So, in this parameter, we need to remember this value and units, what is the exact value for the each parameter, and the standard deviation as well as we need to remember here. So the microstrip line is useful for interconnecting the components in microwave circuits. In the active device, another important factor is MMIC capacitor. Both overlay capacitors and interdigital capacitor can be used in MMIC technology. Interdigital capacitor can be used for value up to approximately 1 picofarad, above which their size and the resulting distributed effects prevent their uses. The most popular type of capacitor has become the MIM. It means metal insulator metal capacitor, which is shown in figure number 1, because of high capacitance per unit area that can be obtained. Therefore, smaller and less costly circuits are possible. The thin film capacitor is composed of two metal plates separated by a dielectric material layer. Typically, the dielectric material layers overlap the first metal layers, and the second metal has smaller area than the lower metal area. The area of the air which post determines the capacitance value. The thickness of the dielectric layer is fixed in these open foundry services. The capacitance is approximately linearly proportional to the air bridge bimetal. In terms of this active device, it is called the spiral indicator. And due to its high Q factor, the spiral indicator has become popular and it is shown in figure number 1. And the Keiko company provide two types of square spiral indicator. One type is shown in figure number 2, is a structure of entire air bridge or air bridge post. In case of this, the size of the air bridge post is 1 micrometer smaller than that of the air bridge microstrip line. On the other hand, generally other type of inductor is formed from a microstrip line through use the outward shape and has an air bridge in one portion. The partial air bridge posts are marked D in the figure number 3. An indicator is also commonly specified by the numbers of turns and microstrip line width and inner diameters. In the discussion of active device, here we have included resistor. The resistor in an MMIC technology can use the doped semiconductor layer of a deposited thin film resistor layer. In this case, the material of resistor is an nickel chromium thin film. Sputtered thin film resistor offer improved linearity and low temperature coefficients in comparison to the others. So, in the figure number 1, we can see the configuration of the resistor. In this slide, we will focus on biahole and FAT. The backside of the bioholes are used to connect the device or RF circuit on the front side, and the metallized backside for the grounding and thermal dissipation. The configuration and physical parameters of biah are given in following figures, as we can see the figure number 1. After that, the physical parameters of the biahole. For the physical parameters, we need to know the three important things. One is biahole shape, and second one is unit, and third one is standard deviation. The biahole shape in the name in terms of inner diameter, the front side, the unit should be 33 and standard deviation should be 10%. The outer diameter in the shape of the back side, the unit should be 75 and the standard deviation should be 10%. And the diameter on the marks layout, the unit should be 50 micrometer and the standard deviation is mentioned here. And the thickness of the gold metal on the back side of the gallium arsenide offer, the unit should be 7 micrometer and the standard deviation should be 10%. And finally, the thickness of the gold metal in the biahole, it should be 2.5 micrometer and the standard deviation is here 10%. So it's all about the biahole and pad. Here we will focus on layout design rule. In terms of layout design rule, it is very much important to know that relatively few design equations are used in the description of passive devices because they are highly process independent. For a particular MMIC fabrication, the manufacturer's design manual is essential for the authority on the exact design rules for device layout and as well as appropriate design curves and equation. So, in terms of this layout design rule, we here included the general consideration. There are some general consideration. Here I have included the first of all I have included the maximum stripping tile size on the offer. The stripping tile size is generally the first thing that must be considered here. So in the figure 1 we can see the configuration of a stripping tile. After that we need to focus on the transistor orientation. For this region, for the sum region, as the first consideration, the emitter direction must be a common parameter. This is shown in the figure number 2. And the prototype MPW16 marks layout. MPW16 is an abbreviation for the time of multi-project offer. As mentioned previously, user may share the offer during the manufacturing process. And in the figure 3, we can see the MPW16. And finally, GDSII stream file format and standard cell. When the layout database is submitted, it should be in GDSII file format. So these files are also used to unify the entire set of chip of offer, and additionally it enclosed a pattern what is shown in the figure number 4. The pattern is applied on the metal layers. In this layout design role, we will focus there are some types of design, and first of all we can see in the figure number 1 an illustration of the layout design rules. There are some figures: configuration, width and length, spacing of layers to layers, and extension of layers to layers, overlapping and surroundings. So in terms of width, we can say here in the figure number in the table number 1, the shorter dimension of this object in any direction on the named of layer. In the length, we can see here the definition of the length is the longer dimension perpendicular to the width on the named layer. For the spacing, the definition of this spacing is the distance that is separating all pairs of object either on the same layer or between two different layers. In the extension case, in terms of extension, the amount that is an object one layer must extend beyond the edge. For the overlapping case, we should know the amount that an object one layer must overlap another object of another layer. And finally, the surroundings. The surroundings, if we want to define these surroundings, then we need to understand the degree which an object one layer must be completed surrounded by another object of the layers. Here we will focus on layer description and based on knowledge on process. In the layer description part, we can see here there are 19th layers used in the fabrication process of Kako company. The full name of this layers ID are shown in the table below, and each layer is described below. All the components will consist of this layer. The following section presents each device. Some of these layers are used independent of other requirements and others should be designed. So we can see here the layers name and the layer ID and digitalized area on mask and photoresist. And for the layer ID, I have just summarized some of the layers name: emitters contact and emitter isolation, first base pachyderls, base contact, second base pachyderls, collector contacts, isolation mesh each, nickel chromium resistor, first nitrate via interconnected metal sheet, interconnected metal, and second nitrate via air bridge post, air bridge metal, final passivation layer, backside via backside subscribe street. Furthermore, in the next slide I will go in details for these some layers patterns, and I will discuss about the some layers in details in the next slide. In this slide we will see and we will focus on concrete of layout design roles. Basically, these following design roles are specification for the rougher as given by the Kako company. And first of all, we can see nickel chromium resistor. In shortly, we can say NCR. In this figure, I mean the figure number 1, this is the layout design rule for the nickel chromium thin film resistor. And there are also included some parameters which is not specified in this slide. And in the second figure, we can see the interconnected metal sheets. In shortly, we can say IMS. The IMS is a layer that is patterned before sputtering the sheet metal for electroplating. In the figure number 3, this is called interconnect metal. In shortly, we can say IM. The IM is the first layer of metal fabricated by electroplating system. In the figure number 4, this is S and B, and we can say here second nitrate via. This is the figure number 4. And the figure number 5, it is called air bridge post, in shortly ABP. And the figure number 6 is illustrate air bridge metal. In shortly, we can say ABM. This is the design for ABM. And figure number 7, it is called FPL, final passivation layer. This is the design for the final passivation layer. And the after that, we can see here the pad. This is the design of the pad. and then we can see the transmissional line. The transmissional line is composed of two layers. One layer is IMS, another layer is IM. Previously I mentioned about what is the IMS and what is the IM. This is the figure number 9. And lastly we can see the cautions. This is the design for this caution, so IMS and the combination of IMS and IM. In this slide we will talk about layout design rule. Design rule check, in shortly we can say DRC. DRC is an abbreviation for the terms design rule check, and it is very much important for the engineer to check all or part of the design where we can confirm it is reach out to the manufacturing specification. In generally there are two types of DRC. One is quick check, another one is custom check. And this DRC procedures is given below. First of all, we can see here the define or select a design rule. After that, run the design using define or select rule, and then load the result, and finally we can view the any error that where we can found or not. This is all about the design rule procedure. And here we can see the figure number 1. If there is any message for the window, then we can get this kind of view. And figure 2 and 3, here we can see the two windows for the quick check and for the custom check design DRC. Thank you everyone for watching this presentation. If you have any question, then you can ask me in the comment box. Thank you once again.